it's William from Metric Fabricator. Who is ready to draw something fun? This is like the most microscopic automotive piece of hardware I've ever really had. It's hilarious. This is Honda Insight rear hub. It's the older Insight. It has a tone ring. The newer ones, the Fit and the Insight, share the hub, and they are a magnetic ring. This thing is awesome. I want to use it for the front of a mini buggy, two-seater. You could use it for a smaller buggy, one seat, if you wanted to never change it ever, never have to have a problem with it. It would kick ass. It's decently lightweight. It would be good for a small road car front knuckle. We'll build the spindle. It's got like a 22mm center bore, which is horrifying on a car, but sick for a buggy. It's Honda, 400. It's got light holes that are lightning. I mean, what more could you ask for? This thing is epic, so let's draw it. I want to give you guys the files. We'll probably end up charging for the Fusion file, but we'll see how it goes. Let's get started. So, sketch plane, I draw on the side. So, I start with a side profile and do a revolve. I find that easiest. Construction. So what I do is draw as many segments as I believe it'll need. So inner wall of the bearing, center. Now the center wall has, like, you can see there's just some goofy radius. That's fine. We'll go up from there. This is the top lip. We'll go down. As you can see, the next step is there's a small radius. We're going to ignore that. Then we're going to go over, down. That down step will be for where the brake hub goes. It's really thick. 3/16 on that. I don't think we'll be using that. I want to design studs that bolt on a like 1/4 inch thick, just laser cut steel solid rotor brake. Let's go all the way out, dip down. We'll just put this little bit of degree down. As you can see, the bottom of the hub does have like this just gradual and then radius and then another gradual neck to where the tone ring is. And look at how bad that is. So break this down, connect that. Now we got a piece that is kind of what we're starting with. So you can get to the bottom easily. Grab your finest calipers. Yeah, everyone would be mad. Mitutoyo or whatever. Alright. I'm getting 23. We'll call it on the nose. My 0, 0, 2, 0, 0, 2. We're fine. Alright. Most of the bearings I find are pretty much dead on. So 22 divided by 2. There's our half. 11 millimeters. 11. Great at math here. Anyways, let's find a depth. I was going to bring in a washer to level this because you can see the tone ring is just proud like a military. It's so expensive. We are literally 2 mils from the base. These all feel dead flush. So we're going to we're just going to 0 that 175 to the floor. You won't be able to. Maybe. We go on the inside. 39.84. These are loose. Obviously, drive them out if you want to like, or get a big venereal caliper. 39.82. We'll do 39.8. We could double check that later, but for the sake of moving on. I love it when you start the drawing sometimes and you start dimensioning, your start goes absolutely crazy. Dimensions are pulling it all over the place. But let's do 0 or caliper again. Let's try and get this brake hub. We can actually double check on Rock Auto, like the actual hub. We're at 61 on the nose. So let's do. Forgive me, sometimes I still am terrible at this. This bore is going to be your wheel bore. 5602. 56. I don't have Space Mouse, and I don't have my CAD mouse in here. I'm inside. Power went out twice already. Probably do it right in the middle of this. Watch. Right. Inner bore. Maybe I should have this face, you see. Definitely kind of arbitrary. 51 should be fine. This one's not going to be crucial. So I'm going to change. Alright, as you can see, this is another favorite of mine. When you change one dimension, it decides to just pick whatever it wanted to do. So the bore of this, there is the seal. Not that it's insanely crucial for building what we want to build out. It looks like it's about 2 millimeters thick. It's a little sweep. But I'm gonna just guess with the inside of this. 49. That's my guess for that. Not a crucial part. We're not building this hub, we're using it as a representation. Yeah, see, that looks about right. And on the inside, that radius, yeah, it's start. Call it 16 millimeters. .25 millimeter. It's over that. We can radius it when we get in. Nah, we'll make it. Let's make it 1 millimeter. And we can radius both these together. Call it a day. That's that. What's our major OD? Re-zero. Maybe clean out the inside just in case. Get a good 0. Don't push too hard because you can bend. We're good 0. 133.7. Obviously, there's better equipment, better stuff to do, but not everyone's going to have thousands of dollars of calipers. Let's do 133.75. Oh, there's my other favorite. Just move the projection of it over. Now let's drag that down. Yep. Oh, maybe I should divide it by 2 then. There we go. That looks better. Gets this on edge. So we also have a non-machine surface. You can see this is from the casting. Probably a drop forge casting, so they'll take a rough and smash it while it's really hot. We're still hot. 4.5, about 3/16. This is called metric fabricator for a reason. Let's reach down towards. We're going right at the base of this cutaway. I'll try and put those in later for fun. Well, actually, if we're going to do that, we're going to do the inside of this one and then add the material. Wait, we're at 8.75. Excuse me. Eight point 0.75. All right. I'm not going to knock this off now. I'm just going to make it up. 59.2. We'll probably end up deleting this and making it some sort of kind of arbitrary arc. I'm actually not going to dimension this way yet. I'm just going to leave it. We can pull it around, make it look right. It's kind of I like dimensioning pretty heavy, then getting to stuff that I can pull around just by feel. If I like it, then fine. So, yeah, get a 55 55 millimeters on the inside. Still 175. 0. It's on the inside of that dust seal. 19. And the stepped radius is 7. There we go. We got something. Let's actually make something that looks like something. So, finish the sketch, revolve, click, do your job. There we go. We have a kind of hub. Right now, I think it looks pretty good. So let's turn the sketches off. So let's just put some holes in it so it feels better. I'm gonna put our 12 mil bolt holes in first. I'm guessing our knurling cut out 11.86. Yeah. Other than knocking one out, but we can find that out later if we do end up building our own studs. Already forgot. 11.79. Just drawing this so they can stay equal to each other. Let's see, how big is the relief hole? Maybe I should do that so you can see it as well. Read it upside down. Oh, adjust the 4 and 100 after I read. Around a circle, grab these two. Outside ring. Okay. Just measure. Align. 100. These two guys. I don't have a set of calipers that has the opposite on it. We could zero one out and go the stretch. I got 99.13. We can also. I got 98.95, so we're gonna go 99. Cool. Yeah, looks about right. Turn that sketch back on. I'll turn that off. All right. Let's put in some radiuses. And how about the center board? We actually didn't do that. 20, just over 23. So we're going to call it 23. I already did that. No, I did 20. Hopefully the AI video editing's really good. Yeah, 23. So we're good. Check things. I'm dyslexic, left-handed, got everything going on. Cool. Let's put in some fun ones. Not that they even matter. This radius right here looks like it just flows. We're just gonna pull it out level 2.5. We're gonna actually add. This is all vibes. It actually doesn't reach that far. So what is that? About 9.5. It looks a little more than that. We just need to bring that taper in. If I had to guess, we can do chamfer. Inner is probably just a nose radius from the CNC programming because it's as tight as it can go. And it looks like there's a small radius on the base underneath that. So we'll just add that one in. Get all the radiuses done in one job so we don't clog up our drawing. There we go. So this obviously looks like it has way more taper. Like, let's see. By the time we're up top, it should only be 61 millimeters wide. Yeah, 66. So we need to shave like 5 millimeters in. I'll just do it by hand. So, right, measuring. Look at that, 61. Who knew? That radius does look like it goes well into that. It might even go further. I'm going to make it a little bigger because then the reliefs go on the outside of this leaf. It's not really a big deal that we put all that in, but it might be fun. Let's do 12. Let's go to 14. It'd be hard to do a drawing on this, so we're probably going to do a projection off this drawing around this, and we'll just give it a little flower. Check that out. So, guess on diameter 27. Let's actually draw an inner circle so we don't get this all over. Circle. Tangent. Then we'll make them the same. Can't really measure how far they go in, so cut 32 millimeters wide. 76. So I'm going to draw another circle and make it sketch line. 76 millimeters. X for sketch. The nice thing about sketches, see how this lights up because there's a closed loop. Now it's a sketch. Oh, there's still other loops in there, but it'll, if you have a bunch of stuff going out and you're just drawing, you can turn it into a sketch and now everything won't be a closed plane that's flashing every time you go over it. So from this point to this point, I'm actually going to put a point in. The one time I ever use one. Use it so much. There it is. All right. What did I say it was? 31? Not everything is 100% precision. Did you see that? It moved. This thing loves dimensionally moving because I did not do it right. I drug it over. The other thing you could do is move it like this, put in your own construction, tell that construction to be straight. Now, see how it turned black? Everything is constrained now. So when you change something, it'll all change. We're going to send this. Just so we don't have to make it later, extruded, cut, or whatever, or clicking. I could mute the feature. I'm going to go back in there. Just the showing's going to be great. Watch after the edit. Look like I'll draw this thing in like 30 seconds. Yeah, we don't want to cut. Let's join. Look at that. Something. 8 millimeters. -8. Let's just put this chamfer on. Mind you, if you do all this stuff and it's struggling on your PC, like you don't have to do this. Because once you save this file and you bring it in as a component to save your whole system from going haywire. Actually, I wanted to add that chamfer on the same time. So add +1, this. You gotta thank the fusion gods. Okay, so we're at, it's just crazy pull. So let's try, you can see this inside radius. That's the one I should have done. So I should do 16 on that one and 12 on the other. 10. So we can go back into the old one. This chamfer set, let's do 10. How neat is that? Chamfer on chamfer, I don't care. I'm kind of happy with it. It looks dope. Now, this 8, actually, that real effect. Up in new. Since we started on the center, everything is based on the center origin, which is great. It's hard to see what's. There's a little radius on there. Suppose we can do another one. Getting a little muddy, but it'll look cool. Guessing 2. Awesome. On the top here, let's see. We got 45-degree chamfer on the top. My guess 0.75 and about 1.5. Hard to tell. A quarter. It's hard to see. We can just, yeah. My guess is 3/4 and 1.25. Both on the same profile. Seven five. There's definitely more meat, so we're gonna do point. All right. Now we got a hub. What time is it? 11. Tomorrow. Let's put some studs in. Talk about what we'll do. Maybe we'll build a spindle for it. Let's see what we got.